the actual number values associated with it. Okay? So I would assume, right, most people have a general idea of what I mean when I say an arc. People say, draw me an arc. I would assume people would go, there's an arc, right? So the essence of what we're talking about here is the arc is just a part of the circle, right? So you basically are taking the circle, looking at a small chunk of it. And we're only talking about right now the outside portion of the circle. All right, so when I say a small chunk, I mean like if I got the circle drawn that way, I'm just looking at it from like here to here, just the outside portion. Not talking about area today, okay? Just the outside part of it, the measurement around the outside. All right, so anything up there that would be colored, like the black portion would be an arc, the blue portion, the red portion, all those would be different arcs. Okay, don't worry about this drawing right now because you're going to have drawings on the next one. So just the basic idea about everything we're working today is just parts of the outside of the circle. Not the exterior, but the actual circle part, okay, going around it. All right, so for the first part, okay, the first thing is just classifying them and naming them. Okay, classifications, guys, if you look up there, two of the classifications are on the circle, okay, the one that's drawn. And that would be major arc and minor arc. There's one other classification, and that would be a semicircle. Now, the difference between them is just the number of degrees they take up in relation to the entire circle. Right? If I go all the way around the circle, there's 360 degrees, correct? Okay. So everything's pretty much going to be in relation to that, but it's when we write these out in terms of minors and majors, it's always dealing with a half circle measurement. Okay, and half of 360 would be 180. All right, so you've got minor arcs, which minor meaning smaller, right? So this would be all again in relation to a half circle. So anything smaller than a half of a circle would be a minor arc. In terms of degrees, it's from 0 degrees to 180. All right, and guys, the degrees is the arc measure, which is going to be different than, like I said, the arc length at the end. Measures always talk about how many degrees it takes up. So you got minor arc from 0 to 180. Don't just say less than 180 because less than 180 implies negative angles, which you guys don't deal with. Major arc from 180 to 360. Okay, so in between those. If you're at it, and when I say in between, right, if I'm exactly at 360, it's a complete circle, and if I'm at exactly at 180, it's a semicircle. Okay, so those are the three classifications. All right, now, I'll probably, in terms of this stuff, like I might give you a circle and say, here's an arc, classified as minor or major, which would be a pretty easy problem. You just look at it and see whether or not it's bigger or smaller than half a circle. Now, for me to identify the arcs I'm talking about, we have to be able to name them. Okay, and the way you name them deals with the points on the circle. Okay, and between the three classifications, there's going to be specific ways that you name them depending on if you're talking about a minor arc, major arc, or a semicircle. Okay? All right. Can I go past this, guys, just for the right foot? The picture is going to be on the next thing. The picture's not going to share. Just don't think it does. Okay? Go on. Okay, now, the way you name arcs, guys, what I said was based on the points on the circle. The two main points that you always use are going to be the endpoints of an arc, such as the minor arc up there is the red one, the major arc is the blue one. If you were to just trace it around the circle, I mean, you would see that the minor arc right there starts at A, right? it goes to B. Or vice versa, starts at B, goes to A. It doesn't matter. Either way you go, you're encompassing that entire arc. So since I can see there's an obvious start and stop point, these 2 points right there for this minor arc would be the end points, right? That's an end point. So that. Okay, so if I was to name this arc right here, I would call it arc AB. Okay, and since it's a minor arc, I'm using, like it says up here, just 2 letters, just the end point. Okay, and when you write it out, you write out the 2 letters, and then you just put a little arc above it, like that. Okay? Now, the next one, okay, the minor, or the major arc. I'm still going to be using endpoints, right? And if I look at the one that's on the picture that's up there, right, the major arc, if I trace it out, right, from the blue, it's starting at the same point, it's ending at the same point. So my endpoints here are still A and B. The way you decipher between them, or the way you show someone that you're talking about a larger arc or a smaller one, is that when you do major arcs, you pick one other point that's on it, and you stick it in between the endpoints. Like in this case, C is also on there. So if I was naming that one, I'm going to name it ACB or BCA. Okay, the order of the endpoints doesn't matter. It's just that when you write these out to indicate that you're talking about a major arc, you're going to use 3 letters. Okay, 2 of them are still the endpoints. So I'm still doing A and B. It's just that in between them, you just put one other point that's on the arc. In this case, C is the only one that's shown, so I can just use C. If there was more than 1 points on there, it wouldn't matter which one you pick, as long as it's also on the arc. All right, and like I said, guys, order doesn't matter between the endpoints. Like for the minor arc, I could have also done BA instead of AB. This one I can do BCA. It's the same thing. Okay, the only thing that matters is that when you do these, especially for the major ones, the first letter and last letter have to be the endpoints of it. Okay, and also like the way I have this listed, telling you minor arcs are 2 letters, major arcs are 3. That kind of keys you off into which one there that you need to find an answer for. So when we do the problems that I'm about to have up there dealing with measurements, if you see 3 letters, you're probably going to have an answer that's bigger than 180 degrees. Like if you go to your circle and you try and figure out the measurement of the specific arc, and it's got 3 letters there, and you come up with something less than 180, it's probably not the right answer. Okay, because in general, 99% of the time, if you see 3 letters for an arc, it's going to be a major arc. Okay, now, the other one that obviously is not up there would be the semicircle. Okay, with the semicircle, you're still using endpoints. If you are just indicating that you're talking about half a circle, and it doesn't matter which half you're talking about, you can use 2 letters to name the semicircle. Such as if I extended this line out, it's over here, and create a new point, right? That would be a diameter, right, all the way across. Remember that's what it's called. We talked about circles before. A diameter, guys, always makes a semicircle. Okay, if I was talking about a semicircle in terms of this drawing up there now, since I've added that line, if I just said, where's the semicircle, or name the semicircle, and I don't care if you're talking about the top or bottom, you could just say BE. Okay, that would be a semicircle there. Now, if I wanted you to be more specific, and I said, name the semicircle on this part of it, you would have to name it the A. Okay? Semicircles are kind of odd because either one fits. If it's just 2 letters, that's fine because you don't really care about positioning. But if I wanted you to mention either the top part or the bottom part or left or right or whatever, then you have to throw in 3 letters. Okay, the 3-letter one is only if you are concerned about which part of the half circle it is, either the top, bottom, left, right, whatever. Okay, so with semicircles, it doesn't matter either way. Okay? All right, now, the measurement portion of this. Can I go past this? Yeah. All right. The central angle that's up there. Okay? Central angle, just like with polygons, guys, it's the angle at the center. The way this relates to measurements. Because right now I'm only dealing with measurements of arcs, which measurements are degree measures. Alright? The central angle, it's always going to be equal to whatever the measure of the arc is. If you read through any of the definitions for this, talking about how they relate, you're going to see it's going to say something like the measure of the angle equals the measure of the arc it intercepts. This is the central angle. When they use the words, the angle the arc intercepts, the whole intercepting just means that if you take the sides of the angles, right, like this angle right here, and I just extend it out, whatever arc is in between those two sides is the one that's intercepted. So like if I looked at this angle here, it opens out, and if I extend those lines out, I can obviously see this arc is in between it. So that means that arc AB is intercepted by that angle. Okay? Which would mean if I knew the measure of this angle, like if I just said the measure of the angle AEB is, how many degrees you want to be? What does it look like? It is 45. 75. Okay. If I said that angle is 75, that means that in turn I would be able to figure out both the measures of the minor arc and the major arc in this case. Okay? The minor arc would be exactly the same as the angle because if I trace the sides of the angle out, that's the arc that's in between it, okay, which means it's intercepted by it. So I would say that the measure of arc AB, and remember the little m in front always means measure. So when you see that little m in terms of arcs, guys, it's asking you how many degrees it takes up. So if I said that angle is 75, the arc's also 75. So 75 degrees there, 75 degrees there. But like I said, in turn, if I know this is 75, I can figure out what the rest of it is also, correct? Well, how could I figure out, just based on that, what the major arc is? Yeah, so for the other one, I could just do 360 minus 75, 285. Okay, so then I would know also the measure of arc ACB. So the major arc is 285. Okay. With problems like this, the biggest thing to do, especially going from angle measure to arc measure and so on, is just figure out what angle the endpoints encompass. Okay, and that'll always give you the answer for these in terms of measurement. All right. So like, oh wait a second, I can't go on here, right? Can I go on? Sit here. All right. So like, if I gave you this one, like if you had a picture like that, and I asked you to find different arc measures. Like if I said we'll find the measure of arc FE. We'll do measure GF. We'll do measure of. We'll do these four. The whole idea with a picture like this, especially where there's multiple lines, is whenever you go to match up the arc to the angle, right? And I would match it up exactly because these are all central angles, so that's the center. Okay? I would just go to the endpoints, like FE is the first one. So okay, angle F, or point F's there, point E is there. So this is the arc I'm looking at. So if I just go from those endpoints back in to the center, basically what I'm doing is I'm tracing out the angle I need to look at. All right? So obviously if I trace that in, I would see that angle is 110, and this is 10. All right? What about the next one? What is it? I did. Okay, so she's saying if you add up all these angles, subtract it from 360, you get the other angle that's here, it's 130, right? Okay? And again, the reason that's the angle you look at, right, is the two endpoints of GF are there and there. If I trace them back in, that gives me the angle to look at, which is 130. Okay? What about the next one? What about GE? 120. So we're going to agree that it being 120? Is that okay? Right? So G is there. E is there. If you trace those back in, you see that it takes up that entire angle. So that entire angle is 80 plus 40, which is 120. All right, what about the last one, which is the only major arc? 240. Okay, because it's, since they threw the F in there, I knew that I'm looking at this arc here. Because the endpoints were still GE, but I had to pick the one that has endpoints at GE that also included F. So it was those two angles together. Right? It's not that hard, guys, but you gotta, like, if you have trouble seeing them, honestly, just draw all over the picture. Mark it up, draw angles all over the place, something so you can see which ones correspond. Okay? All right, so, this. All right, so now the next part's going to deal with the length. Okay? The length of an arc, guys, this is dealing with no longer degree measure for a final answer. It's going to be involved in the formula, but the actual answer you guys are going to get is going to be related to this measurement here. Right? Circumference was always just a measurement around the outside of the circle, the perimeter of it. So when I do arc length, guys, is just a portion of the perimeter. So just to remind you, right, that was the formula for perimeter by R. Done that multiple times in the past, shouldn't be any surprises there. Okay, so just to remind you of it. So what we're going to do, again, since an arc is essentially, guys, just a certain portion of the entire circle. Okay, anytime you do portions, it's like a percentage, right? Percentage are essentially ratios. As soon as ratios come into play, you just set a proportion. So what you're going to do for these arc length things is essentially you're going to set a proportion up. All right? The way the proportion goes, right there. Basically what you're doing is you're doing the ratio of the lengths of the arc in the circle. Yeah. Right there.
Oh, okay.
Yeah. What one? 2 pi r?
Yeah, I just see it.
Guys, essentially the way this works is you're doing two ratios. One ratio is dealing with the length. Okay, length being, again, how many feet the arc takes up, inches, centimeters, like actual linear measurements. And then what you're doing is length over length. Okay, the difference is on the way these ratios are set up is you have the arc on the top, the numerator. On the bottom you have the entire circle. Okay, and the length, technically the length of the entire circle is the perimeter of it. That's why the 2 pi r is on the bottom. That's your circumference. Okay, so it's always the length of the arc over the length of the circle equals the number of degrees in the arc over the number of degrees in the circle. So it's always just arc over circle equals arc over circle. It's just different measurements. One measurement's dealing with degrees, the other one's dealing with the number of feet, inches, centimeters, meters, whatever. Okay? Now, here's the thing with this. There's only one number up there that doesn't change. That's the 360. Which means technically, right, there's three places I can plug in numbers. I can ask you to find any three of those at any time on any problem, but I would give you the other two measurements. So you might see a problem where you're given like the arc measure, which would be the degrees, right? That would be the little m part. And I might give you the arc length and say, what's the radius? Or I might give you the radius in degrees and say, what's the arc length? Or I can give you the radius and the arc length and you find the degrees. So there's basically three different problems that could come about from this one proportion. Because there's three places you can plug in numbers. Now the place that doesn't change is the 360. Okay? Alright, but otherwise, guys, the problems aren't anything more than, it's going to be a pretty basic proportion. Alright? It's just a matter of you have to make sure you're doing the measure correctly, which relates back to the central angle stuff we were talking about. You have to make sure you get the radius correctly, or if they give you length, so on. Okay? Can I go on past that stuff? Is that okay? Alright, so here's the thing. I'm going to go through these three problems. Alright? The first one here, what we'll do is this one's going to be find the length of arc AB. This one is find the circumference, and this one's find the radius. Okay, and I just want to point out the way some of these measurements go, guys. If you, like on 9 and 10, the ones that are labeled 9 and 10, if you just see this number here, like just sitting on the outside of it, what they're saying is that that arc is 24 centimeters. And again, guys, if you see units with it that are not degrees, if there's like regular units there, that's talking about the length of it. So when I plug it into that proportion we just had, right, and the proportion doesn't change, right? The proportion is, right, arc length over 2 pi r equals the measure of the arc over 360. Okay, that's not changing. The only thing that can change is the different things I give you to plug in. All right, so like number 7 would be the most straightforward because it's finding the length. So if I was setting this one up, I put my variable there, the thing I'm trying to find, right? It's the arc length, that's what I'm asking to find, so that's where we go. What's the radius there? 7.5. Measure of the arc here is 50, 360. And now guys, what I want with answers like length and stuff, leave your answers in terms of pi. Meaning don't make that a decimal, guys, just leave pi in there. Alright, so before I start cross multiplying, I'm going to simplify this as much as I can. So 2 times 7.5 is 15, correct? Right? It's 150 over 360. As a quick thing to do, if you want to drop the last digit, that's fine. Okay? Make it 15 over 36 because it's basically dividing them by 10. Alright? It just gives you smaller numbers to work with. Alright, so that when you do your cross multiplying here, right, and guys, just remember back to like the sine, cosine, tangent. I'm not going to do a full cross multiply here because if I multiply the 36 over to solve, I'm going to divide back by it anyway, so I'm not even going to be worried about that. All I'm going to be worried about is getting that 15 out of the denominator. So on top, I've got x equals, what's 15 times 15? So the answer here is going to be 225 pi over 36 inches. Now, I would like you to reduce fractions if possible, okay? But if you take time in reducing it originally, you probably aren't going to have to worry about that too much. All right? Obviously, I know I could reduce this further. Okay, now the next one here, the number 9 one. The one that says find circumference. Again, since I got this number here, and I know that 24 centimeters represents arc length, I have to use the same proportion. Anytime arc length comes up, guys, this proportion needs to be used. So the thing is, when I write this one now, so for 9 it's going to go 24 2 pi r equals the measure of the arc, right? That's the measure is the number of degrees that goes with it, so that's 135 over 360. So 360 never changes. Now here's the thing with this problem, okay? Because guys, on number 10, it's going to be set up the same way. The difference is when I do 9 right now, the one that's 9. If I'm finding circumference, I mean, you guys agree circumference is 2 pi r, right? That is the formula for it, correct? So what I'm going to do is I'm going to change this a little bit so that it says 24 over. This will save you time, okay? And I can even make these smaller guys. We just drop 0, basically move the decimal place back 1. It gives you smaller numbers to work. Now when you do cross multiplying here, I'll get 13.5c equals, what's 24 times 36? 64. And then to get c by itself, which is circumference, I'm just going to divide. What's 864 divided by 13.5? 64 centimeters. If you would have done it this way, like some people will go about finding the radius and then taking the radius and plugging it back in, they're probably not going to get exactly 64. Okay? All right, now, on this last one, right, this formula is not changing. We're going to find the radius. So that means I know the arc length. So that's 36.8. The 360 doesn't change. The only thing that changes is the number on top. In this case, it's 260 because the 260 goes to that arc, all right, where they've got it. And I remember I said I know this is arc length because I've got units with it on the number on the outside. Okay? So, in terms of solving this out, this become, right, 36.8 over equals 26 over 36, or 13 over 18, or whatever, however far you want to reduce it down. It's just equivalent. If I do my cross multiplying here, what is 36.8 times 1324.8, and then what's 26 times 2 pi? Like actual decimal, the whole thing out. Like actual 26 times 2 times 3.14. 26 times 6.28, whatever. Oh,
Just to put the zeros on 216 and this one.
was that?
Just put the zeros on 226.
No, I had it here, but if I see 0 on the end, I can just
Yeah.
get rid of it. It won't change your answers, just make smaller numbers to work with here. All right, and then divide this up. So 8.1. So here's one thing also, guys. With these problems where you're finding arc length, I would prefer to be finding it As long as the radius is an easy number to work with, like 7.5 is easy. Like if your radius was like 8/10, you want it to be easy. If it's like a decimal, like they have a weird decimal, like it was like 6.85 or 897 or something like that, then obviously I wouldn't mind you making everything a decimal, just multiplying everything out correct. But ones like this, where you find the radius, it makes more sense to go ahead and do 2 pi together. Get 6.28 just for an estimate, and then use that as this number instead of leaving pi. Okay? All right, so